In problem number 26, we have an issue of matrix multiplication, and we have a matrix equation actually. So it says, which of the following is a solution set of the matrix equation? Then we have the matrix 1, -1, 1, 3 times xy. Now what we do, those two matrices next to each other, means that we have to multiply them. But before we can do matrix multiplication, we have to verify a few things. First of all, the first matrix is 2 rows and 2 columns. So I write it in this way, it's a 2 by 2. The second matrix is 2 rows and 1 column. In matrices, we always refer to the row first and then the column. So we have a 2 by 2, 2 rows, 2 columns, and we have 2 rows, 1 column. Now in order to perform multiplication on two matrices, we have to make sure that the inner part, or the connection between the column of the left side matrix and the row of the right side matrix, are the same number. If they are not the same, then we can't proceed. But if they are the same, the resulting matrix will have the dimensions given by the row of the left side matrix and the column of the right side. So in order to perform matrix multiplication, the column of the left side and the row of the right side have to be the same. The resulting matrix, if they are the same, will be the row of the left side and the column of the right side. So let's see what that looks like. So we set up the two matrices next to each other, and what we're going to do is multiply the first row, first column of the matrix on the left by the first row, first column of the matrix on the right. So we're going to multiply 1 times x, and that just gives us x. Then we're going to multiply the first row, second column of the matrix on the left by the second row, first column of the matrix on the right. And that gives us -1 times y, or negative y. Then we're going to jump down to the second row of the matrix on the left, and it'll be the second row, first column times first row, first column. Or again, 1 times x for a value of x. And then we'll multiply the second row, second column by the second row, first column. And that gives us 3 times y, or positive, or plus 3y. And so we have x minus y, then x plus 3y. So for every row in the matrix on the left, there will be a corresponding row to the matrix in the answer matrix. Then for every column of the matrix on the right, there will be 1 column in the resulting matrix. So we have the result of the multiplication on the left side of the equal sign, and we want to set that equal to the scalar multiplication of the matrix on the right. Now the scalar multiplication is just a number times a matrix, and the way we do that is we multiply every element of the matrix by that number. So the scalar 2 times the matrix xy becomes the matrix 2x, 2y. Now since those are equal to each other, when two matrices of the same dimension are equal to each other, then that means that all of the elements in the corresponding positions among the two different matrices are the same. What does that mean? Well, the first row, first column of the matrix on the left is equal to the first row, first column of the matrix on the right. So x minus y is equal to 2x. And similarly for the second row, first column of the matrix on the left, and second row, first column of the matrix on the right. And then I'm just going to take these two equations and solve them with all the x's and y's on one side. And if I do that with the top equation, I'm going to get x plus y is 0. If I do the same thing with the second equation, I'm going to end up with the same exact equation, x plus y is 0. And that really means that they're the same equation, so we don't have two equations for two unknowns, so we can't solve it any more than that, except to say that any number where x is equal to -y, which means opposites, will be a solution, and that's answer C.